Hello, everyone. Today we are going to go through Leetcode 146 LRU Cache. The problem statement is design a data structure that follows the constraints of least recently used cache, LRU cache. Implement the LRU cache class. Firstly, LRU cache init capacity. Initialize the LRU cache with positive size capacity. Get function returns the value of the key if the key exists. Otherwise, return -1. Put function updates the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from the operation, evict the least recently used key. The functions get and put must each run in O1 average time complexity. So here, if we do some O1 average time complexity for get and put, we can intuitively think about the map to maintain this kind of access. But here we need to maintain the least recently used term. So every time when we put and get, we need a mechanism to maintain the order. So double-ended linked list can be a good candidate to maintain this order because we can get the first order, last order, and then remove the item, add one item in O1 time complexity. I need key value. So at first, I initialize a dummy node of the double-ended linked list. And so here, that's defined node. Key value. Now, this is a double-ended node. So for get, we returns the value of the key if the value exists. So we need to check if key is in the if it's in the dict. We can say not in the dict. We return -1, and then if it's in the disk, we need to get this node and then return the value. But we need to maintain the status of its order because we do a one-time access and then we need to adjust the node to the first place of the of our linked list. So we can come up assume we have a function, we remove it from the node and then add to the add the node to the first place, just adjust the order. We don't create and delete new item reference or instances. For put operation, we better check if the key is already in a cache, we return the value. We update the value. Otherwise, add the key value pair to the LRU cache. And then we need to check if the number of keys exceeds the capacity from the operation, evict the list recently used key. So we need to check get the list. It's from list one is evict the list recently used key. So here is the basic structure. And then we here we need to initialize the LRU cache with a capacity size. And then that's prepared to help function. Because it's a double linked list, we just simply do, let me see, A, B, C, and then I want to delete B. We want A to C, and we want C to A. So no, this node is B, node next, and previous it's node previous, and so we want to add this to dummy. I want to have the dummy new. I want this one. And we have next. And update the next previous. Yeah. Okay, so let's do the test and see whether we have LRU Cache line 23 add first. There is a typo. You can get everything correct now. So let's went through the code, like we init the LRU cache with the capacity, and then we prepare the a map to support the O1 access, O1 access time, and we maintain a double-ended linked list to maintain the order. And every time when we do a read, we need to adjust the order of the element to put the latest accessed node to the first place of the cache. And when we do the put operation, basically update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of the key exceeds the capacity from the operation, evict the least recently used key out of the cache. So let's submit the result. Add first. So 41. Yeah, so typo here. Okay, here is the solution.